I'm back, and now we're ready to take our lesson quiz. So question number 1, why would the brightness of a star make it difficult to detect whether it had any planets? Well, it's because the star is so bright. So the brightness of that star would overwhelm the light given off by any other planet, and so that means it would be difficult to be able to see them. Question number 2. If a planet is in orbit around a star, the gravity of that planet will cause the star to do what? Begins with the letter W. Wobble. So that star is going to be moving back and forth because that star is in orbit around its center of mass. So remember the teeter-totter thing, that the pivot point of the teeter-totter, that would be where the center of mass is located at. And so if you can imagine that teeter-totter able to rotate around its pivot point, then that's what the star and the planet would be doing. They would both be in orbit around their common center of mass. Number 3, if a star is moving, its spectrum will be what shifted? Begins with the D, Doppler. So it's going to be Doppler shifted. So meaning that if the star is moving towards us in its orbit, see it's going around in an orbit, which means sometimes the star would be moving towards us. So that would mean that its light is going to be blue shifted, or the frequency is going to go up. And then sometimes the star is going to be moving away from us in its orbit, and so that's going to be red shifted, and then the frequency is going to go down. Number 4, if a planet moves in front of a star, the brightness of that star will do what? It's going to get dimmer. Number 5, if the mass and the period of a star is known, what third law can be used to determine the distance to an orbiting planet? Kepler's third law. Name a molecule that a planet would have in its atmosphere that would indicate that it was Earth-like. So what are we looking for in the atmosphere of these various planets that we are discovering? Oxygen. So we need to find a planet that has oxygen, because that's probably going to mean it's got photosynthesis going on, and then that would be a good world to be able to colonize. Number 7, most of the planets observed so far, are they Jovian planets or are they terrestrial planets? They're actually terrestrials. So we found more rocky planets than we have gaseous planets so far. Number 8, the current theory of the solar system formation explains how a Jovian planet could be inside the ice line. That is true. So now Jovian planets, they form outside the ice line, but they can migrate. So their orbits can change so that they can end up inside the ice line, very close to their stars. And so that's it. So we're now finished with unit number 2 about the solar system. And so my next series of videos will be a review for my students for the Unit 2 exam. And then for the rest of you who are just like watching these videos, then stay tuned for Unit 3, which is going to be on stars, star formation, and star deaths. So I'll see you then.